Hello everyone. Today I'm going to briefly touch Azure fine-tuning. So fine-tuning is a way to improve an LLM. You can use it, let's say if you have new information that you want to put in your LLM, if you want to put some additional information into your LLM. It is in a sense similar to RAG because in a retrieval augmented generation you have your data also that you want to let's say to use in a sense while getting some results from LLM. Well, this is similar, but unlike RAG, where the RAG is kept in a separate vector database and is his how to say weights are kept separate from the LLM. In here, in the fine tuning, the fine tuned LLM is actually can or has weights inside of it. So let's see how Azure does it. So in Azure Foundry, you have the option to train LLM. There are several options to train LLM. And actually, I trained one model. And let's click the fine tune and let's see how it goes. So these are the models that can be fine tuned. Now, other models can also be fine tuned, but again, this is just an example. So this is an example of how to fine tune a model that is text based. Yeah. So we'll go with GPT-4 Nano. And about fine tuning, well, the interesting thing is that it is a rather complex operation and it is a rather costly operation. So fine tuning itself takes a long time and deployed fine tuned models cost you money even if you don't use them. So, for example, if I would now the model that I fine tuned before, if I would just deploy it, even if I use it or not, it would cost me, I don't know, 3.5 euros per hour just to have this model running, just to have these models deployed. So be careful. Now, you can start actually from base model, or you can start from fine-tuned models. Yeah. Now, unfortunately, we cannot do it here, but it should also be an option. Okay, about fine-tuning, some, or how to say, certain options can fail, but there are many ways to fine-tune a model. So what I'm showing you now is fine-tuning through the web interface, but you can fine-tune the model also through command line interface, and you can fine-tune a model also through, for example, through Python application. Yeah. So if this fine-tune doesn't work, for example, in this fine-tuning, and we'll try it, I could not just upload my training data. Well, it just did not work directly. But when I went through the Python, I was able to upload my data and then to fine-tune the model with this data. So I think this is still a technology that is in development. So yeah, be gentle with it. So let's go next. We are not going to fine-tune this model. Fine-tuning, apart from taking money, and I already did fine-tune one model that I will actually showcase, it also takes a long time. So I fine-tuned a model with test data of around 150 queries, and I will show you the test data very, very soon, and around 40 evaluation queries or validation queries. And it took around 45 minutes to train this model, and this is the smallest model. So it just takes a huge amount of time. It can take I would say many hours to train a model with a slightly large data set. Okay, then this is something we'll talk very soon. So there are several different methods to fine-tune a model. One is supervised. In the supervised model, you deliver your training data and your evaluation data, and that's it. Then in direct preference optimization, you deliver your input data, but the input data is organized in a different way. So in the supervised model, you have the input data and the expected output data, and then this is what the system tries to match the input data with the expected output data. In the direct preference optimization, you can say, okay, this is my input data, and these are the options that I consider correct, and these are the options that I consider incorrect. So the mapping between the input data and the output data is a little bit different. And in the reinforcement method, then the reinforcement is used for more complex models, for models that usually do some reasoning, for example. And then the input data is input data, but then the output data and the way that this output data is actually matched to the input data is done in a different way. And I will discuss this also soon. So now let's say this, you choose supervised model, training type is global, or it can be also regional, and global offers cost saving, but then your data can be everywhere, and regional, if you choose your data stays in the E region. For me, it doesn't matter. Now you can add the training data, and I said I tried this. Just you can also choose training data from different sources. You have some curated data sets from Azure itself. Then you can get it from files from connected AI resource. You can upload files, or you can get these files from Azure Blobs. For example, in here have some files, and you can see it immediately get these files. And actually, this is maybe if you want to do this basic training, you should put the data probably in to be your data resource, and then use it like this. Yeah. So that is it. And you can have also the validation data. You have the suffix. The suffix is something that, like a tag, a way to tell, okay, this is the some kind of description of my model. A seed, you can put a seed, and then every time the training is done, it starts with this seed. It's a random seed, and then your random generator follows this seed, and then in a sense, your training is similar when you use the same seed. Then the batch size, this is how many of the examples in the training set are used, what is the percentage of them to be used for training in one epoch. This is learning multiplier. I'm not really sure what this is used for, but yeah, they said it's a fine general learning rate. Original learning is for pre-training multiplied by this multiplier. Yeah. Anyway, it's you can keep it to default number of epochs, how many full cycles through the data set. What Azure AI said is that usually 3 is enough, but it's up to you to decide. Okay, and then if I would have all the data, I would just click submit, and the system would start the training, but I will not click submit because, again, I don't want to do this. I can tell you this, that I have this model. So this model is like any of my other models. Yeah, it's completed. It's now I can download this. I can see how it was done. I can download the training file, so I can do here several things. I can use this model. Yeah, so I can say, okay, now I want to deploy this model. Yep, and this one is called delete ASAP because it shouldn't be deleted. And actually, I will deploy this model. I will deploy this model, and then I will show you the differences between when this model is called and when the normal model is called. Now, the deployment also takes some time. So you can see that usage of the model is very similar. So you just change your deployment name, more or less. Previously, we had the GPT 4.0 Nano as a model name, but then this you say, okay, my deployment name is actually now this one, and then you just use your normal approach to how would you call these models. Now, it takes some time to provision this model, so we'll have to wait until the provision is done. Okay, well, this is being provisioned. Let's go into the data files and actually in here. So in here you can add data. Yeah. So you can say, okay, I want to add data for fine tuning, and for fine tuning, at least you have, well, for this supervised tuning, you need at least two sets of data. So the train set and the eval set. The train set should be bigger than the eval set. These are JSON-L files, which are very similar to JSON files. And actually, I will show you now how these sets look like. So it's a list. Again, this is not a proper JSON because this is just a list of JSON entities. And then each entity has some messages, and then you have the system message. So it is like you can see it as it's normal interaction setup. When you interact with the model, you also have these kind of message. So you have the role of the system, and then the content is now you are secure coding a system, and then what is the role of the user? The content is, okay, give me this explain broken access control, and then the assistant gives result back. So this is what fine tuning uses to fine tune the model. It uses the system content, and then what is the user request, and what is then the response of the assistant. So the idea is that the user request together with the system prompt is then matched to this content, and then this is the idea of this fine tuning. And then for each of these inputs, and you see this is the input file, it has like 150 input messages, and then the evaluation file is around 40 messages, and it is also very similar. Yeah, it's again, you are secure coding, so it has the system content, the user content, and the assistant content, the response content. So let's see, is our model now deployed? No, it's still not deployed. So let's go then and discuss different types of fine tuning. Yeah, if you go into the fine tuning documentation for Azure, you can see in here there is a lot of information of how you can fine tune. Some models are supported. You see that there's only 8 models were supported. Some others are not supported. This is from the fine tuning. This is how you do it. You prepare the data. You have the file format. You can actually I showed you file format where you have just how to say one turn chat, so with system prompt, with user request, and then system response. But then you can also have multi-turn chat. You can also have chat completion with vision, so you can also use images to train or to do fine tuning. Then data sets, and this is what I showed you how to craft it, and that's more or less. Now this page actually displays information for the supervised training. Then I told you there is a direct preference optimization, and I told you that this is different because there is an input, but there is also preferred output and not preferred output. So this has a slightly different, let's say, input setup, and then data is again in JSON-L format. But the idea is that there is for a certain message, there is what you want the assistant to return and what you don't want the assistant to return. And then there is another way, it's reinforcement fine-tuning. And then actually this type of fine-tuning can only be done with Azure OpenAI O4 Mini, which is a reasoning model. And it's much more complex. So what does it do? Well, the training data is different. Yeah, it has it only has the role of the user, and it has then the solution. Yeah, and final answer. And what is actually the idea with this? The idea is that the fine tuning uses something called graders to assess the quality of model response. So what you say, okay, uh, this is what my user request is. This is my perfect response, and then I will make a grader that will make a gradation between what the LLM that is being fine-tuned returns and what is the perfect response. And let me give you some more information when they when with the different types of graders. So this is string check grader. String check grader is return 0 or 1, and the most simple is EQ. This means that uh, this grader returns 1 if the output of the LLM that's being fine-tuned is exactly the same as you wanted it to be, as the preferred output, as the solution output. And you get differently. You get 1 if the output is not equal, and 0 if the output is equal. Like is if the output and if the input contains the reference, actually, then it's 1, otherwise it's 0. Then uh, so these are string check. So it's very string checking is very strict. Then you have the text similarity, which is much more nuanced. So you can say, okay, now this is my request. This is the output that I want to have. Now, whatever I get from LLM, well, I will have some text similarity, and then there is different evaluation metrics for this text similarity. And then based on this text similarity, I will the LLM will then fine tune itself. For example, if the texts are very similar, then it's good. Then you want to go that way. And I would expect that is the let's say just normal way that LLMs would train themselves anyway. Then there's a score model. Uh, Score model then uses another LLM to score the results based on uh, your perfect result and the result that was received. A score model are used to score the difference between these results, and then you can also have custom code graders, which are Python code that you can say, okay, now this is my sample and this is the item. Give me now the difference between these. And then also you can have multigrader. So the multigrader combines the output of multiple graders to produce a single score. So this type of fine tuning is the most complex, but also the most powerful. Now let's see if yes, we are now succeeded. So let's go and open the playground. And then we say here, okay, we use this model. Yes, and then we give him the system context as it had, and then we'll ask him one of these questions, for example. Let's say one of the training questions. Okay, so what the user say? Prevent critical web failures in a RESTful API, give a short checklist. Yeah. So we say this, and we got this AO2, critical web failures, focus on TLS hard crypto, safe serialization. Left out of the A02. And actually we can see that this is very similar to what was given as a result from the evaluation as the assistant. Yeah. Now, let's say that you want to ask the same question to the normal model. So I will say GPT-4 mini that I have. We make clear chat, yes, and then we ask the GPT-4 mini. And then you see this the result is good, but this is a generic result. Yeah, this is a generic result that that doesn't fit what we wanted the model to return. So yeah, this episode was about basic fine-tuning of Azure AI Foundry models. Thank you for your attention.